Morning, everyone. Am I audible? Okay. So in the last class, we discussed about one defect of human eye. Can anybody name that defect which we discussed? Just repeat me. What defect we completed discussion? Hello.
Myopia.
Myopia. How did I name that defect? Remembering the name, or directly you are able to get the name? How did we name that? Just based on the assumption, right? So for the correction, we have method that is virtually showing the object as image, right? Virtually the image of the object showing to the person who is suffering from that defect. So that correction already we have shown yesterday, right? So what is that? Using concave lens. So virtually you are forming the image of the object which you placed at infinity distance at a point called M. So the image of the object for the infinity distance brought virtually to the point M. So this virtual image will act like object for the person. This image viewed by the person on the surface of lens. So this image rays will be refracted and converged on the retina. Are you clear about the discussion yesterday? Or is there any confusion to ask me? Everything is clear? Everything is clear? Yes. Anybody? Tejaswini, Rohit, Abhinay? If there anything, just ask me. Okay. So let us start a new topic, that one more type of defect. So for this defect also I am following the same process. I am not announcing the name of the defect first, right? Just I am assuming exactly opposite to the yesterday's defect. So yesterday I thought if I placed the object at least distance of distinct vision visible to the person clearly, right? In today's discussion, just I am realizing that opposite, right? So here external view of eye. So schematic diagram, that outline of eye is drawn. Then I'm showing you the principal axis. Then here a point identified, that is the distance where we can see the object clearly in front of eye without any strain. That is given as least distance of distinct vision. I am identified that. Okay, so here just object is at infinity, suppose, right? In this case, no representation of object here, just will consider the parallel beam of light rays from the object. So in this case, I am assuming this person is able to see the object clearly. So very far, very clear. Object is very far, it is very clear to the person, right? So here slowly we started bringing that object towards the person. So from far distance to near distance we are observing. In yesterday's discussion, near distance to far distance. In today's discussion, far distance to near distance. So in this case, at infinity, where is the image formed by the eye lens? Can you see the image in this case? Where it will be? Anybody? Where the image formed by the eye lens?
On the retina.
On the retina. So the person is able to see the object at infinite distance or not? Person,
Yes, sir.
yes, able to see because the image formed by the lens exactly on the retina. So in this case, image on the retina. Then let us consider another. So here I am getting the object from infinity distance to the near, right? Not to the L, just getting. So in that process, I am always asking the person, is he able to see or not? Right? Always I am asking the person while I am getting the object near to the person. So here he will respond me, right? Where he is unable to see, that we will find out, right? So here exactly that point, okay, where he is unable to see, that point I will find out. If I come inside that point, person invisible, that object invisible to the person, right? If I go beyond that person, beyond that point, or exactly to that point, the person is able to see. So I'm coming from far to the near. So that's why at what near distance he is able to see clearly, that point is given by me as near point, right? So I know that 25 centimeters. Now I place the object at 25. Okay. So if I place the object at 25, what happens? Right? I am assuming this person unable to see. That means what? That eye lens forms the image on the retina or before or beyond the retina. Where will be the image? If the person is unable to see the object at L. Where will be the image? Person assumed invisible the object, not visible. So in this case, the image not on the retina. Okay, not on the retina. I got it. But will it be before the retina or beyond the retina? That I need. Okay, so here, if the object is at infinity, what will be the maximum focal length of eye lens? It is given as 2.50. So this distance will be adjusted, right? 2.50. Okay, then if the object is visible at this distance, f minimum will be 2.27. So this distance exactly will be adjusted, right, by changing the shape of the lens, right? That is equal to 2.27, right? But in this case, I assumed person unable to see. That means no image on the retina. So will it be 2.27 or above 2.27 or below 2.27? Anybody? What the focal length will be? At this distance, person unable to see the object, inside also unable. Then what will be the focal length? Is it 2.27 or less than 2.27 or greater than 2.27? Can anybody guess?
Greater than 2.27.
So why we are taking greater than 2.27? 2.27 only the minimum focal length. There is no eye lens less than 2.27 for a healthy person, right? Only depends on the flexibility of ciliary muscles. Only for the age group below 10 years, they may have, but we won't consider, right? Because in that age, less, very rare cases with this eye defects, right? That is the reason to avoid that. Okay, so f minimum will be greater than 2.27. So this distance will be set up more than 2.27 for the converging of light rays, because after refraction that light rays are going to be converged at a focal point. So that will be set up 2.27. So where the refracted light rays are going to meet each other after refraction, it is at focal point, that is above 2.27. So that refracted light rays are going to be converged. beyond the retina in this case. Have you got idea why they are converging beyond the retina here? Everyone, have you got idea why they are beyond the retina? Right? So here it is based on the focal point adjusted by the lens. So how it can set up focal point? Changing its shape. So that is the reason to say that converging point will be beyond the retina. But in your textbook directly given, they are converging beyond the retina. So how we can remember? It is difficult. So go with the logic. Easy, right? So I consider two cases, right? So in the second case, image is on the retina. Image is on the retina or beyond the retina. Image beyond the retina. So no image on the retina in this case. Image not on retina. So this will be considered as defect. Are you clear? How I got this defect? So now I am able to define the defect. Yes. Here the person is able to see the far objects that are infinite distance and unable to see at least distance of distant vision. But here it is not the meaning. The person is unable to see nearby objects. He can see somewhat nearer, but not at 25, more than 25. The person is able to see the nearer object about 25 centimeter distance. So let us assume up to what distance he is able to see, right? So I'm considering one more situation here. Taking that eye lens, drawing the principal axis, then locating the least distance of distant vision, right? So I know already if the object is placed at L, person invisible. That means unable to see the object at L. But if you place the object beyond the L, he is able to see. But at what distance? So that distance I am going to find out now. So assume person is able to see up to somewhat this distance, right? That distance I am taking eyes here. Suppose I moved beyond the L. If he is unable to see, is it near point? Because here I got the image beyond the retina. So in this case also he is unable to see. No image on the retina. So this is also defect only. But if you move further distance beyond that, what happens? He may see. So I will draw one more diagram here to get that a point, right? Beyond the L. So that point I am representing as H here. At this minimum distance beyond the L, it is only nearer distance. So that's why it is called as minimum distance. To see the object by this defect person. So here, if the object is located at H, the person is able to see, right? Because practically I am finding. I will ask the person at what distance he is able to see. So for that, I am representing the diagram. Person able to see the object. That's why the image taken on the retina. So here the image will be on the retina. The image will be on the retina. Right? So in this case, image on retina. So is it defect? No. So here look at the four diagrams what I am given. Here the first one, object is at infinity, image on the retina. So it is no problem, no defect in this case. Last one, if the object is at H distance, that means minimum distance to see the object by this defect person, there is no problem because image on the retina. Look at the middle diagrams, two diagrams. If you place the object at L, image not on the retina beyond. If you place the object between H and L, so here just imagine at this point as H. So here object is at between, here object between H and L. So in this case also person is invisible. So if the object is located in between near point and least distance of distant vision, person unable to see with this defect, then what to do? If the object is placed at L, that must be brought to the H. Are you clear? Are you clear? where actually he is unable to see? Where actually he is unable to see? Can anybody give me clarification? What is the defect
Sir,
of
at
person?
point L.
Yes, at point L, unable to see. Right? At point H, he is able to see. Here visible, here invisible. Right? So in this region, he is unable to see. If he is able to see in this region, right? If able to see at this distance, any distance he can see, because infinity is there, then we need to show the object which is at L. So what is possibility to correct the defect? What the object is placed at L distance, that must be visible to the person. So how we can visible that object? How we are able to show that object to the person? We are unable to move the object. So what we'll do? We will get the image virtually of the object which is placed at L to the H. Right? So for this, we will use a lens to form the image virtually for the object position L at H. So now I am defining this defect. Can anybody define this defect by seeing the diagrams? Observe the diagrams. Observe the diagrams. Define the defect. What the problem of this defect person actually? Able to see the far object, but unable to see the nearer object. So this defect I am naming as farsightedness. What he hides visibility clearly, that name I am giving. So this farsightedness also called as hypermetropia. This is also called as farsightedness. So what is actually farsightedness person defect? Unable to see the near object, but able to see far object. So this you can write as definition. Everyone clear how I defined? Based on my assumption only, I am not remembering that. Just am assumed the defect of the person. So if he is unable to see, automatically the image will be before the retina or beyond the retina. That before or beyond will be decided by taking the focal length for that particular position. Right? Then how to correct this defect? Already I told you. We need to get the image of the object which is placed at L virtually to the point H, because at H near point the person is able to see. So this is the minimum distance to see the object clearly at H. So that H is given by me as near point. The distance between the lens and the near point H is called as near point distance. That we will take it as some unknown value. Right? So how to correct this defect? So correction of the defect. Right? So here, what is correction of defect here? Simply what I assumed, that object which is placed at the L distance, that must be brought to the near point H virtually. So now the object is at 25 centimeters, we are assuming. So which lens will correct the defect? Is it concave lens or the convex lens? How we can decide? So here, if you use concave lens, what happens? For the infinity distance also, it can form the virtual image, right? And the smaller image will be formed for the very far distance. He cannot see properly, right? So here we can select convex lens, because except one case, in all the cases, it will give you real image which cannot see that through the lens. Through the lens, we can see only virtual image. So here the suitable lens is double convex lens. So the double convex lens we can use. What happens if we use double convex lens? I assumed already I have to get the image of the object which is placed at L distance virtually brought to the H. So I am assuming with this lens the image of the object at L distance, right? That light rays focused on the external lens. What happens when they refract through this external lens? Will they converge or diverge? right? So here principal axis, a light ray along the principal axis, it cannot deviate from its path, so it is straight. Then it is making angle. Here in this case, what to do? We need to assume something, line passing through the principal axis optic center that must be parallel to the incident light ray, as we discussed in the example number 4 or 5 of your lesson number 4. Are you following? That same logic I am using here. So here, before refraction to the external lens, the light ray assumed parallel. So what happens after refraction? It deviates and maybe converge at a point. Maybe converge at a point to this lens. So if you extend these, will it converge or not? Yes, converge, right? So here also we need to assume a parallel ray to the incident light ray. So it may be converge at a certain point. But these light rays are going to converge on the retina by the external lens? No, it is not possible. So here that can form the virtual image here. We need to go very far distance, right? It is not possible. If you go in the backward direction for this, that can form virtual image at a point H, right? So as assumption only it is, right? For that assumption, practically I can find out the focal length to give that image exactly at H distance. How do we find out? Right? We will see. So here image brought at a H, right? After refraction, it is not forming the image. Virtually, by the diverging rays, it is forming the image. So in this case, I got the image virtually at H. So I will get the image virtually at H. So virtual image is magnified and enlarged, right? So that image will act like the object for the person because he is able to see that image on the surface of lens, right? So here that object, from that he is receiving the light rays, right? So these light rays will converge and meets exactly on the retina, right? So this forms the image. So here now the image on the retina. So what will be the image distance here? Virtual image only we will consider because I am finding the focal length of external lens. So for that image is at H. So image distance is near point distance. We can assume that near point distance, right? So here that distance I am taking as small d. Just logically I used the distance also. Capital D used for 4-point distance. For large, that's why capital is taken. Near point distance, smaller value, smaller letter indicating small d. Right? So clear, everyone? That also I am following logically. Small d, capital D. Right? Assumption, 4-point distance, capital, large distance, capital D. Right? Smaller distance, small d. Right? So I assumed for the external lens only, don't see the eye lens. We are unable to change the focal length of eye lens. So I am not considering anything related to the lens here, eye lens, right? Only I am considering external lens. So for that object is at L distance, 25 centimeters. So take the object distance, right? And substitute them in the lens formula. So 1 by f equal to 1 by v minus 1 by u. I know that is lens formula. But what is the focal length? Here focal length of the lens, I will take it as f only. What is the object distance in this case? U equal to 25 centimeters. According to sign convention, we will take it as negative. Then what is the image distance? It is formed at a near point. That distance I assumed as small d. It is also measured in the opposite direction in the incident light rays. So taken to be negative. I know u value, I know v value, then what is f equal to? We can find out. Substitute that value in the relation lens formula. So 1 by f is equal to 1 by v. It is minus d. Minus, already in the formula, 1 by u is minus 25. So minus 25. Then solving negative symbols in the denominator. So convert that to the numerator. So 1 by f equal to minus 1 by d, minus into minus plus. So plus 1 by 25 we will write. Then LCM, that is 1 by f equal to, here LCM is cross product of denominators, direct product of denominators, then cross product of numerators. So direct product of denominators will give you 25d. Okay, cross product of numerators, 25 into minus 1 into 25 plus 1 into d only. Why? 25 into d is 25d, or d into 25. Then solving. So 1 by f is equals to first positive term 1 into d, the next negative term minus 25, right, by d into 25, 25d. So you are writing here reciprocal. So if I write reciprocal, what I will get here? I'll get f is equals to 25d by d minus 25. Right. So this is the required focal length of a convex lens to correct the defect hypermetropia. Right. So this is the required focal length of a eye lens. Right. Using this convex lens, image will be formed at a distance called near point. So like this, you are correcting the defect hypermetropia. So now respond. Are you clear about this defect, or there any confusion? Rohit, okay. Surajita, okay. Abhinay, given. Kaushik, everything fine?
Sir.
Clear defect? Yes.
Yes, sir.
Then we assume two situations, right? What there? For the first defect, from the near I started, visibility for invisible, right? For the person, second defect, I started from far is clear, near is invisible. So now the situation, I am assuming far and near both are not clear. Far and near both are not clear. So there are no diagrams in your textbook, right? There are no diagrams in your textbook, but we are able to expect that, right? So I will show you that diagram, but don't draw in your examination, just for our understanding only. Just for our understanding only, I am showing you that, right? So here it is. I'm taking outline for that. Drawing the eye shape. So this is the protrusion part of your eye. And here we need to cover it completely. Right, I got the shape using the zoom. Right, then here assuming that person is unable to see far objects. So what the defect diagram will be? What the defect diagram will be? Like this. So here I assumed what it is, principal axis, right? So we need to have the eye lens here. So I'm showing you the eye lens with the different color here. So eye lens. Then here object will be assumed placed at infinity distance. So infinity distance will consider only the parallel light rays. Parallel light rays. Then after refraction, what you can expect? I'm assuming the defect, the person is unable to see very far and very near. Very far, if not visible, where will be the image formed by the eye lens? Is it on the retina, beyond the retina, before the retina? Compulsory answer. Anybody?
Before the retina.
Why before the retina?
Unable to see far objects.
Okay, why I am expecting that before the retina? Why should I? Actually, F maximum is 2.50. The distance will be set up maximum 2.50, right? The person is unable to see the maximum distance. So, person's focal length will be less than 2.50. So, the converging point of light rays will be given by the eye lens. In this case, will be located before the retina. So, that will be like this. Are you clear? Are you clear? Just it is myopia person defect, right? If the object is placed at least distance now, object now I am placing at least distance, right? So here I am showing you the least distance at a point here. So least distance point shown. Then I need to get light rays onto the eye lens here. Okay, from the object. So this one remains undeviated along the principal axis. Then what about the top and bottom ray? Will they converge on the retina? Will they converge on the retina? No, right? They cannot converge on the retina. So where they converge? Before or beyond? Anybody? Before or beyond? Object at L distance, F minimum will be expected 2.27, but the focal length of this defect person will be greater than 2.27. So this distance set up 2.27 by the lens if it is healthy, but unable to set up 2.27. It is above. So that light rays are going to be converged beyond the retina. So both are defect, right? Unable to see the infinity distance, right? Unable to see the infinity distance and unable to see the L distance. But in between them, the person is able to see. In between them, the person is able to see. So this is predicting the defect. Clear? Clear? There are no diagrams for this defect in your textbook. There are no diagrams in your textbook, but practically we are able to draw the diagrams like this, right? Then we'll go for the next. How to correct the defect? What is presbyopia defect actually? So let us continue this discussion in the next meeting. I'm closing this one. Join immediately.